the lab. And I guess the first question is just like, okay, like why? What are correlated subqueries? Like why do them? For me, correlated subqueries, when I think of it, I just immediately think it's a nested loop, right? Like that's essentially the functionality that it's giving you, right? Is that we have, either one table where we'll loop through the same data twice, kind of, for each row, perform another query, or we can do this with two tables, right? Where same kind of concept for each row, query this separate table, find something associated with that particular row. And we said that we can kind of think of our subqueries as one, like a more fine-grained window function, right? We'll see that in a little bit, or a more fine-grained join, right? So again, it's like kind of starting, why do we even need to know this thing? Sorry about that. Thank you, Pankaj. I'm using the wrong term. Correlated subquery, I should say. Correlated subquery. So, okay, so we're loading some initial data, and what we're starting with in this lab is, this product information, and then it says, use a correlated subquery to add a column of the minimum price for each product category. And kind of right off the bat, when you see this problem, you should actually not probably be thinking a correlated subquery, but rather a window function, because minimum is a window function that we can use, and it's probably a little bit easier, but we want to get the hang of our correlated subqueries. So for me, the way I do this, I hope, is just select all from the outer table. So that, select all from products, and then I can call it like P1 or P, whatever, and have this just work, right? So I just started with the outer table, give it an alias immediately, and now once that works, then move on to the subquery part, right? So what do we want to do? We want to find the minimum for each product category. So you can see these have like these accessories, right? And then there's a minimum price of the water bottle is $15, and these are more expensive, the sunglasses, backpack, etc. All right. So we know that in the correlated subquery, we always are going to be, it's like a where clause, and then we're going to be referencing that outer table. So select all from products, and this will be like, you could give it P2, but I don't think you actually have to. It will say where products dot, like what am I joining on? So it's for each one of these rows in the outer table, I want to find all the products that match in terms of the accessory. So where products dot, in terms of the category equals P1 dot category, right? And now I want the minimum. So I should be able, there's only one, like I don't need a group by, right? Because it's only going to get one category per subquery, right? This is, for the first guy, it's only going to be all the accessories. So now I should just be able to do min, right? Min of the price. And, right, so select all from products P1, get all the rows, and then for each one of those rows, line up that row's category, P1.category, with, query the table again, this products.category, and then see the minimum price from that set, and I broke it because P2, no such column products.category. I guess I need to do P2.category. Okay, that's better. And we should give this an alias as minimum price. And let's see. And let's order by the category, descending, comma, price, descending. That's probably fine. Maybe price should be ascending. But, okay, so here's our electronics. We see the minimum price is $150, right? And that's why it's listed on both places. Here, the minimum price of clothing is $20, and that's why it's listed in both places. It probably makes sense for us to have the price actually be ascending. It's just a little bit more clear. 150, 600, 20s, right? 50. There's only one price here, and then here, 15s. So this all lines up. Okay. So again, nested loop. The order of operations is just like doesn't match the syntax. That's what's maybe confusing about this. But select all from products P1, giving this an alias means that when I line this up, it's first waiting for the alias to be assigned, and then it's performing the subquery. Okay. All right. Questions about this before we move on? Right, where this becomes more fine-grained, of course, is like if you want to find the second price, right? That's kind of the example I keep giving, where it's like limit 1, offset 1, find the price. I forget the order, if it's limit, then offset. Yeah, so now this is the second highest price is 45 for clothing. Is that right? Something like that. This looks off. Select price from products, pre-category. Oh no, did I mess it up? So there is no second highest here because there's only one, right? There is no second highest here because there's only one. And this is probably the second high. It's just confusing because there's only two. The second highest is $150, right? Let's see an example. Here there's 3 of them. This is not the second highest. That's what's off. Somehow I'm off. Maybe it's offset 1 and limit 1? That's not going to work, is it? No. Yeah, sorry, gang. I'll have to come back to this. Join. It looks right to me. Oh well. All right, I'm just gonna move on, and we'll debug that later. Okay. Well, the next kind of harder problem is this related to correlated subqueries. Is this dog foods thing? So the problem here is we have these dog foods. They all have a price, and we have these customers. They have a budget. All right. And we want to see, the problem here is find the number of customers who can afford each dog food. So the first thing is kind of figure out your outer query. So that is this dog food stuff. So select all from dog foods, and you can give it an alias of D1, right? Because we want this query to occur first. And then what we'll do is select all from customers, where the customers dot budget is less than or equal to, is that right? Yeah, we need them to have a budget, that's greater than or equal to. Or another way to put it is that the dog foods D1 dot price is less than or equal to the customers dot budget. Right? And now I just want one value here. So really what I want to do is find all the customers who have a budget less than this price, but I want to count them up, right? So it's count star. Count the number of rows where the budget D1.price, where the price is less than or equal to the budget. Yeah, that makes sense. And then that's probably good. Order. Let's just do let's give it an alias. As number of customers. I think that's good. Okay, so 52251. I think that's fine. And the only other request was that you order by the number of customers descending. Order by number of customers descending. Okay. So it's the same format. We query here, in this case we're querying a separate table, and now we're aligning, it's not equals, but it's less than or equals, right? And make sure you're only returning one value, right, for each row, otherwise I won't even know how it could work. So I really think this stuff just takes practice, like more than anything else, but I feel like conceptually you mainly get it. Questions about this, and then I can see, I'm not quite sure, I do have the solution posted, So we could see why we got this wrong. I like to use the royal we when there's wrong answers. Okay, and this is use a query, find the minimum price. That one we did, and now the second most expensive. So order by price, descending, limit 1, offset 1. This looks similar to what I did. I don't know. And this here, notice it is giving us the second most expensive one. So it looks good. Right? Alright, questions about this material? I say,
Yes.
yeah, go ahead, Pally.
Still confused, like when to use this correlated subquery, because when they ask the question, they don't say like, okay, you perform correlated subquery to find this one, or windowing function, or join, because you can get the same result joining two tables, like at a P1, P2, and order by and group by accessories, you will get the same result.
For this one, well, you can't group by in this case, right? There's no group by here, right? Because it's for every single product.
One, if you do the first query, I did it with the join, and no, not the first one, not in this case particular. Yeah, this one you can do it with join.
That's
easily.
Correct. This one you can do with join, or I would probably naturally the first thing that comes to mind for me is a window function, right? Because you can just partition by the category and take them in. But the issue, at least so I think of this kind of like as an alternative to a join or a window. In this case, an alternative to a window function. The problem is, yeah, you can only use the window functions that are kind of provided for us, right? Like min, max, rank, dense rank, right? Order number, right? Whatever they are, or row number, I should say. But in this case, when we're asking for the second highest, there's no corresponding window function. So that's why I say like here it allows us to like more fine grained. I'd have to try it with a join. Maybe you can also do it with a join. That's fine. But I think the question is like when you think of like nested loop, like the way that you're going to solve this is with a nested loop. That's when I would think correlated subquery. All right. Same thing here down below. This let's go. And by the way, this lab is pretty. One thing that I think is good about it is it asks you to takes you through a window function as a point of comparing it. And then, okay, now let's see this other use case. This is not looking for, right? This is two different tables. We're saying less than, like I guess maybe you could do this with a join, but I don't know. It doesn't make sense for me. It's really like for every row, find the customer or find the number of customers whose price is less than where the dog food price is less than the budget, is less than those customers' budget, right? For every row, find the number of customers essentially who can afford where the price is within their budget, right? Or who has a budget greater than the price. Maybe that's how I should word it. So again, it's like when you think of nested loop, right, then we can use a correlated subquery. And like doing this with a join, maybe it's possible, but it's harder for me to rationalize, at least right now.
I think for this one, we can use CTE. Like with CTE, we can just get one output, start from customers, and then you basically
I think it's going to be, I don't know. I don't see, you can try it. I'd be curious if there is a solution. We can kind of move through that. But let's take a look. Lay kind of has the nth value. Oh, there you go. So this is a way, right? So here we do have a pre-built window function that allows us to get the nth value, right? So it's more like, I would say it's kind of like that general point of we have to, with window functions, we have to rely on these pre-built window functions, and with like a correlated subquery, you can kind of write that inner calculation yourself. Okay? We're able to, when you can find an alternative, it's fine. You can use the window function. And then for the same thing for a join, like kind of for these like more customized joins, this is an option for you, right? Is to use this correlated subquery. For each row, calculate this. Yeah. That's how I think of the use case, at least. Is like where my knowledge of window functions falls short, we can then go down here and like kind of code it from scratch, or where now I have to perform a complicated join on something where it's not the values equal, etc. Great, same thing. Okay. For each row, find the set of data, query the table. Right, that's kind of what we're doing. For each row, query the table. Okay, so we won't get to this right now, but next up, so one, I'll publish this, the correlated subquery solution. Work on, if you haven't done this finding gaps lab, do this. I think it's hard. I personally find this hard. But I'd say, especially because they ask you to do this, I believe, with like self joins. So doing this with self joins, I think it's very good. Like both self joins practice, and it uses this correlated subquery to do that. And then we can, I can post a solution. And then there's kind of these classic problems with finding gaps. I'm gonna undeploy this for a second because what I want you to move on to immediately is the data architecture discussion questions. Let me R and Y use, let's say like Y use analytical databases. Like you can start maybe with some of the use cases. It's like, all right, well, we use analytical databases. I'll just put ADBs, analytical databases. One, these are for, queries by internal stakeholders, storing, lots of data. And the consequences of that, I'd say, is one, because it's by internal stakeholders for like, kind of internal analytics. Like we don't care about quick writes to the DB. Not as important, right? Because we do bulk loading. But because there's lots of data, efficient reads then are important. Okay? And then, so basically because they're handling lots of data, there's kind of two things. So there's this handling lots of data. There's kind of two things you can think about. One is like query optimization, and then the other thing is probably like storage optimization, right? And then my brain, like I don't have, in my brain, it's not like I promise I'm not like an encyclopedia. I'm just like, I'm like forcing myself to drill down on this stuff, like as we go. All right, so I don't know what's coming next for me. I kind of have a good idea, but I'm just like, all right, this is kind of how it's organized, right? It's like, okay, we're handling lots of data. There's like this query optimization, and then there's storage optimization, right? So with like query optimization, we have things like columnar, like column-based storage, right? And then actually depending on the database, you have these different ways of doing query-based optimization. So we'll get into this more probably in the next class. But remember with Redshift, right, it partitions the data like across nodes, meaning across computers, and allows for parallel execution, right, with MapReduce. So parallel processing. To query multiple partitions of the data simultaneously, right? And then Snowflake, it also, I believe, it also allows for this, and we can get into the difference, but it also allows for multiple partitions of the data, but I would say it allows for isolated compute. And like in an interview, and I would say, but it allows for isolated compute, and I'm happy to go into more details about that if you want. And then I'll move on, right? Because I'm trying to keep things at the same like level of detail throughout, right? That way I avoid going through rabbit holes and things like that. But I should say, like, in my brain, I am kind of like almost like holding down an outline, and I think it's fine for you to write out a few notes, like in an outline form, if it helps you. Right. So now we covered this query optimization. The next thing would be like storage optimization, and this actually gets into Redshift, where Redshift doesn't do a great job, right? Because as you expand the data, you're also expanding the compute power, right, along with it. Whereas with Snowflake, it seems like a better job, right? It compresses the data, and it's storing on S3. It was like a B right by me. Storing on S3, and it's the problem with storing on S3 is, of course, it's harder sometimes to retrieve that data, but it performs techniques like caching, etc. So, like, in general, essentially we have this different use case for an analytical data, right? So now in my brain, I'm realizing that I kind of went down a rabbit hole, so I'm backtracking and just summarizing. Okay. So it's like, in general, we have this different use case for an analytical database where typically we're storing more data, which means that we have to optimize for both storage of the data and querying the data. And then notice that, and also like with an analytical database, we don't care about writes to the database or optimizing writes to the database as much as we do with a transactional database, because a transactional database, it's users who are writing to the database, right? And they need a response and to move on with their lives quickly, to handle a lot of throughput, meaning a lot of users. Whereas with an analytical database, generally we can do bulk loading of our data overnight, and what we care about is performing queries quickly. And there are different strategies for that. And then one thing all essentially employ is column-based storage, because typically with analytical databases, right, we're querying columns at a time as opposed to a row at a time, right? So notice, like, I'm trying to keep it like in terms of how many tabs, right? How like much I'm like double clicking on each of these. I'm careful not to go too far into them. Right, I'm comparing it automatically against what's the natural comparison is, which is a transactional database, and I'm hitting like a good amount of points, right? And then finally, like, I'm summarizing, as I felt like it was a little bit, I could do a better job organizing my thoughts right towards the end. Is that it? That's about. I think that's pretty good. The one I'm trying to think if there's anything else. Like, you might think about like a stakeholders, right? We talked about that, right? And we did I think like this kind of level of organization of like use case, so that kind of explains the problem, and then from that problem of different use cases comes these two different categories of, all right, let's perform query optimization and storage optimization, and then we can always go deeper into any of these topics as we want. So you can see I'm naturally comparing how different databases perform this, right? Accomplish this. One thing that might be useful with questions like this, by the way, is it's typically okay for you to say like something like, oh, there's a few thoughts that come to my mind. Do you mind if I just jot down a few notes and then that might allow me to organize my thoughts? Something like that, right? And then you can just write down a few bullet points or like a few words, and then you can, kind of give an answer. That way, like, if you feel like, say, there's just like, you're not quite sure exactly how to start, remember, you can just start with, before analytical databases, what do we have? What was the problem? And then what are kind of the features they have to solve it? And try to not go too deep into rabbit holes. So that's why I personally like creating an outline for basically everything. It's almost the way I think. Does that feel all right? Anything I missed or anything? No? Okay. Data lake, data warehouse. I think you all know this, right? One thing confusing here is like it can be storing like a combination of structured and unstructured data. I mean, obviously, like it's like this is kind of the only thing that can, like for unstructured data, this is really what it's used for. But if you don't have a data warehouse, or if you want kind of one single repository of your data, you could, or just store all the raw data here. You could store, right, like these like CSVs, etc., of structured data. Just one other thing perhaps to go over is, when you're thinking about the data, right, there's kind of like unstructured, semi-structured, and then structured, okay? Whereas unstructured data is like text or HTML, right? If I'm storing like Google Books, right, we're storing a book, or we're storing like Yelp reviews, right? Things like that, or then HTML, like the raw HTML, right? Because we may want to hold on to that, because then a year from now, a data scientist says, hey, I want to see how did these Yelp reviews change over time, and we weren't tracking some of that information. We can always go back to the source data then, which is in our data lake, right? The semi-structured data, right? This is our JSON data. Trying to think of anything else. That's essentially what we're talking about, I think, is JSON data, right? And this can have a degree of nesting to it. I'm not sure if you call CSV semi-structured, probably not. And then structured would be really, it's, I guess it would be CSV data, and then, anything from like databases or exports from databases. Okay. So this unstructured, semi-structured, that's like mainly what a data lake is used for, but you could just store like raw CSV data in there. All right. And then what's the cost? Like in terms of, the main difference is, right, data lake, just, the reading did a good job, but I think the main thing probably is just, this is more expensive, right? It's more expensive to store. And then to like coerce the data, right? To structure it. Whereas here, because we're storing raw data, it's, you can just store it in S3, and we don't have to spend engineering time coercing the data, right? And then the other kind of big differentiator I would think about, so one, right, we have kind of like cheaper, and under that we have these 2 bullet points, more expensive. And then the second one is kind of like who's using it. Like this is kind of the other thing. Like why, okay, like who's the user, right? And we know that here we have like machine learning engineers, right? They might care about reading this S3 data and just like having the raw data. Whereas this, right, we probably have like less technical people, right? This could be business analysts, it could be data analysts, things like that, but people that don't know Python, or just like for more regular reports that we want to generate and have this connect to a dashboard. All right, so you can think about the use case too, just like you could think about the use case of an analytical database versus a transactional database. Okay. All right, let's move on to this gaps problem. Why am I going to try this? I don't know. All right, so here's our task, which is to basically find the beginning and ending of our gap. So, and by the way, why am I we're spending time on these problems because they come up in different forms in LeetCode. All right, so it's worth having seen this and having some approaches for it. This is the harder approach, which is using a self-joins. All right, so it's like here's our gap, and actually our gap spans a few different missing numbers, right? It starts at 3 and it ends at 4. And you can see that gap starts at 3, gap ends at 4. The next gap is here. It's just one number. So it starts at 11, ends at 11. And then here's another kind of significant gap, 16 to 19, right? So, yeah, let's try it. So it would be what? We want to select, basically the idea is if we do a self-join where we join on the next number, then some of these don't have a next number, and we'll then find, from there we can find, okay, where we can identify a gap, right? If there's like a null value, say we do a left join or something like that. All right, let's try it. Select all from numbers, N1, left join numbers, N2, and we'll say on N1.number equals N2.number plus 1. And I'm curious, right? So we're seeing, and let's just select, instead of selecting all, we'll select N1.number, comma, N2.number. So this is the number 1, and I think this is the previous number for each of them. So you can see, this 1 doesn't have a preceding number, but it's not a gap. This one does. Here, this is a gap, right? So this is kind of like looking back, and it's actually identifying the end of our gap. All right? So this is all the end of our gaps. We can let's update this as where N2.number equals is null. So is null. Yeah. All right. So these are getting there, right? This one's off, and it should be 4, 11, and 19, I think. 4, 11, and 19 are all of our ending gaps, okay? And then this one, basically we want to remove, there is no preceding number, but that's because it's the minimum. So we can just add a where clause here, where the number is null, and N2.number is not equal to select min, right? Select min of N1.number from numbers, something like that. And then this I should be from N1, something like that. Select min of N1.number from number. I broke it. Near from. Oh, I should probably just put the direct table name. Numbers.number from numbers. Damn it, I broke it. Alright, let's just try this. Let's break it out. Okay, cool. Select the minimum of... Oh, that's the issue. There we go. Alright, so we got this number, and now let's move it back. And let's put that here. Where N2.number is null. Is not? Can I do is not here? I might. Okay. That. Let's do this. Maybe that's it. I want to do N2.number does not equal this guy. But maybe it's N1.number does not equal it. Yeah. So that was the issue. I was doing N2.number, but that was querying this list of numbers. So I moved it to N1.number, which queries this list of numbers, right? And that rules out that initial number of 1. Does that make sense? Right, I did N2.number, and it's saying where does these numbers not equal 1, but none of these equal 1. So instead, I had to switch it over to the right one, to this N1.number, and now it's querying these, right? And now I have this essentially aligned. The only issue I need to do is switch this to n1.number minus 1. Okay? And you can call this like as, what do we call it? Gap end, I believe. Alright, 4, 11, and 19. And then the next thing to do is figure out the gap start. And this is very similar. Let's remove this part. We want to call this the gap start. Here, maybe we can do minus 1 instead of plus 1. Let's see what happens. So this is getting there because this is finding basically the beginning of the gap, but we need to be 3, 11, and 16. Instead, this is, it's 2, 10, and 15, right? So in this case, it's seeing where are all the cases, right? Where are all the cases where there is not a next number, right? Because if this is n2, it's like there is no matching n2 minus 1 can look back and find this original table. All right, so here we're getting this, it starts here, 2, 10, 15, and then here, of course, there's not a next, right, because it's the end of the list, right? So it's like then you basically do the same thing. We want to rule out where n1 does not equal, here would be, let's remove this for now and see how it updates it, and then we'll add it back in. Right, so 2, 10, 15, and 20, right? And then we want to remove this 20. So that's where the max of numbers.number get this guy, right? We want to make sure that this does not line up. I think that's it. Yeah, so now we have 2, 10, and 15. And now from here, we want to get to 3, 11, and 16. So we'll just do, plus 1. 3, 11, and 16. So these now can be our two queries. We have the gap start as 3, 11, and 16, and the gap end as 4, 11, and 19. And we can just combine these as a CTE. So let's remove this. Let's say with gap ends as wrap it, move it over, select gap end from gap ends, and just make sure it still works, and it still works, and then do a comma, and now add the gap start. Right, so this is the same as just like building a function, and then gap starts as, okay, and now let's try that. Select gap start from gap starts. Okay, so we got these. So we have 3, 11, and 16, and then we have the gap end. I think it's easier for me if we start with a gap end, and then we'll try to do a correlated subquery if we can. Okay, so what do I want to do? I have this gap end. I want to comma, add in a query where we are going to select all from gap starts. But really, it's select the gap start from gap starts. And for each one of these, we want to find the largest gap start that's below the gap end. So this is the dog food within the budget problem again. All right. So, which doesn't mean I can do it. Select the gap start from gap starts, where the gap start is less than, we'll call this GE, dot gap end, right? So I have to call this GE, right? So I'm going to give this outer query an alias, and I say where the gap start is less than or equal to the gap end. That makes sense. And then we want to order by the gap start descending, right? Because I want the largest one possible, limit 1. And I don't know. And then we'll say as gap start. Oh, I think we did it. We just reversed the columns, but otherwise somehow it worked. Okay, so here's the gap start, gap end, gap start, gap end, gap start, gap end. Okay, so easy, right? So anyway, I don't think not many humans can write this all in one go. So you basically have to break this out into steps, step by step by step, right? And the thing that we did, we basically used the same technique again and again, right? Which is what you did in the initial lab to identify gaps, which is do a self join, do like a look ahead or a look back, okay, to find the gap start and gap end, and then just coerce the data, right, to start lining up. Add 1, minus 1 here, remove the edges, okay, and then here we finally combine the tables, right? So what's nice about, I think it's like what's nice about this correlated subquery is once we kind of have these two lists, then we can kind of tell ourselves, hey, with the correlated subquery, I can link this stuff together. Like kind of in as much crazy logic as I want, we should be able to find a way to say, like, for each one of these rows, let's find the match, right? And there's a way to do that. So the solution for this is also posted if you want to see that. Any questions I can help with on this? All right. The easier way, let's start going through maybe the easier way to do this, I think, which is you have this select all from numbers, and basically, I'm out of practice with window functions, but we want to create a row number for each one, right? And then you can start to see a difference in the row number, like doing a subtraction, right, will start to indicate a difference in the row number. I walk through it. I don't think I can do it without looking. But finding gaps with window function solution. So we perform this. Select number from numbers. And we do the lead function. This is clever. So now get the next number. And you expect the next number to always, if there's no gaps, to always be 1. So then how do you filter out where there's gaps? Well, where the difference between these is greater than 1, right? And then you're on your way, right? Because now, once you do that, here's your starting point, 2, 5, right? This is our first gap. What's the ending point we want to get to? 3, 4. Well, how hard is that? You know what I mean? So what we have to do is, select them where the difference is greater than 1, then add 1, because this is the beginning of the gap, and this is the end, but these are kind of right, these are the steps. These are where the numbers exist. So you want to find where the numbers don't exist, so you add 1 here, and you subtract 1 there. Okay? So that, I feel like, once you get this trick of, okay, we expect the next number to be this, that's what we expect, work from there. Yeah?